From frying parathas in the morning to preparing curries for lunch, the kitchen simply cannot function without cooking oil. Among all edible oils, palm oil is the most widely used in the world. The clear, golden-colored bottles of oil we see on supermarket shelves are actually made from a unique, bright red fruit. Vast palm plantations stretch across the landscapes of Indonesia and Malaysia, and together these two countries produce nearly 85% of the world's palm oil supply. Home to some of the world's largest processing facilities, these massive factories handle thousands of tons of palm fruit every single day. After undergoing a complex refining process, crude red palm oil enters at one end of the factory, while the clear cooking oil we use in our kitchens emerges from the other. But how does this spiky tropical fruit get transformed into the oil that eventually reaches our frying pans? In today's video, we'll take a closer look at the entire journey, from plantation to kitchen. So, let's get started. Raw material collection and the first stage. The entire process begins in vast palm plantations. Palm trees look somewhat similar to date palm trees, with large fruit bunches growing at the top. Each bunch contains hundreds of reddish-orange palm fruits and is known as a fresh fruit bunch, FFB. To produce high-quality oil, the fruits must be harvested at exactly the right stage of ripeness. If they are picked too early or too late, the oil quality declines and the acidity level increases. Skilled workers use long harvesting poles fitted with sharp blades to cut down these heavy fruit bunches. Once harvested, the fruits must be transported to the factory within 24 hours, as their quality begins to deteriorate soon after being cut from the tree. When truckloads of these bright red fruits arrive at the factory, they are first weighed on a weighbridge. The fruit bunches are then unloaded onto the receiving ramp, where the industrial processing journey officially begins. Sterilization and threshing. Once the fruit bunches arrive at the factory, they are not sent directly into the processing machines. The bunches are extremely tough and compact, so they must first undergo a sterilization process. The harvested fruit bunches are loaded into massive steel cages or crates. These cages are then moved along rail-like tracks and pushed into enormous sterilizers, large pressure chambers that function much like giant industrial pressure cookers. Inside these chambers, high-pressure steam is applied for approximately 90 minutes. This steaming process serves two important purposes. Number one, the enzymes inside the fruits become inactive, preventing the oil from spoiling. And number two, the fruits become soft and loosen from the bunches. After sterilization, the fruits are fed from the cages into a thresher machine. It is a massive rotating drum. As the drum keeps spinning, the fruits are knocked loose from the bunches and fall down below. Meanwhile, the empty bunches exit from the other side and are later returned to the plantations to be used as fertilizer. Processing unit. The separated fruits are then sent to a digester machine. This is a massive mixing machine where the fruits are crushed into a pulp. Heat is also applied at this stage so that the fruit cells break down and release the oil. This hot pulp is then transferred to a screw press machine. The machine squeezes the pulp under extremely high pressure. As a result, a thick red liquid known as crude palm oil comes out from one side, while the fruit fiber and kernels are discharged from the other side. At this stage, the red oil is still not fit for consumption. It contains large amounts of dirt, water, and other impurities. Clarification and purification. The red oil mixture coming out of the machine is then sent to massive vertical tanks. Here, hot water is mixed with the oil. Since oil is lighter than water, it gradually rises to the top, while the sand, dirt, and water settle at the bottom. The oil floating on the surface is then skimmed off and sent through a centrifuge machine, where it is spun at high speed to remove the remaining traces of water. At this stage, we obtain pure crude palm oil. It is thick and dark red in color. Many factories sell this oil for soap manufacturing. However, to produce cooking oil, it must go through one more stage of processing: refining and fractionation. To make this red oil suitable for cooking and give it a clear appearance, it is sent to the refinery unit. The process is carried out in 3 stages. Stage 1, degumming and bleaching. A special type of clay, known as bleaching earth, is mixed with the red oil. This clay absorbs the red pigments and sticky substances present in the oil. After filtration, the oil loses its red color and turns light yellow or golden. Stage 2, deodorization. Palm oil naturally has a strong odor. To remove it, the oil is heated at a high temperature inside a vacuum chamber. This causes the odor-causing compounds and fatty acids to evaporate. As a result, the oil becomes completely odorless and neutral in taste. Stage 3. Fractionation. Palm oil tends to solidify at low temperatures. Therefore, it is cooled gradually. During this process, the portion of the oil that solidifies is used to produce shortening or margarine, while the portion that remains liquid becomes the cooking oil we use every day. Packaging and distribution. The clear golden oil coming out of the refinery is then transported through pipelines to the packaging unit. There, fully automated machines fill the oil into bottles, pouches, or metal cans. Filling nozzles dispense the oil into containers in a matter of seconds and seal them immediately. In the laboratory, the oil is tested one final time for its color, density, and purity. After that, robotic arms pack the containers into cartons. From the factory warehouses, these cartons are loaded into shipping containers and transported by cargo ships to markets around the world. This is how the essential golden cooking oil we use every day is produced, from the vast palm plantations of Indonesia through 6 stages of modern industrial processing.